Hey, we are going to cover balancing equations today, which is like a fundamental concept of chemistry. So, when we want to combine elements together, that's what we write as what we call an equation. So, these equations are, they show how a formula works, or how like you make a compound or a molecule. So basically what happens is, like, for example, we just were studying how to name compounds, and we saw a compound like N2O5, and we learned how to name that. We know that that's dinitrogen pentaoxide. But where did N2O5 come from? Well, it came from taking nitrogen, which we know is diatomic, so N2, and combining it with O2, and that yields N2O5. So this is a chemical equation, all right? On the left side, these are called the reactants. These are called the reactants. The arrow right here, we don't write an equal sign. We have this arrow, dude. And that means yield. We say yields. And then whatever we've got on the right side are the products. All right, so reactants yield products. So here we have N2 plus O2 equals N2O5. Now, you will notice on our reactant side, there's two nitrogen. This subscript means we have two nitrogen atoms. Over here we have two oxygen atoms. But interestingly, on the right side, we have two nitrogens, but we have five oxygens. So how does that happen? What is the ratio between all of these that made this work? So we have to do what we call balance the equation. That means the number on the left needs to equal the number on the right side. So here's what this is going to look like. I'm going to rewrite it. N2 plus O2 yields N2O5. Now we know that these are called subscripts, and they represent how many of each, how many atoms of each element you have. But what we are going to write in front of them now is a coefficient, and a coefficient's a big number. So what that means is we can double an amount or triple it, but we cannot adjust the subscripts. So let's look at this. So we've got, if we keep a tally, over here, how many N's do I have? I've got two nitrogens and I have two oxygens. Over here, I have two nitrogens, but I have five oxygens. So that means that on the left side, I need some more oxygens. Well, the only way I can do that is to double the amount of oxygens I have. So if I have two O2s, how many oxygens do I now have? I have 4. Is that enough? No, I need 5. So therefore, this 2 can't be enough, right? I need more. So what if I triple the number of oxygens I have? Let's say I make this a 3. Now how many oxygens do I have? I have 3 O2s. That means I've got 6. Well, that's not going to work because I only have 5 on the other side. So I can double the other side. But if I double this, then I double the entire N2O5, which means now I have 4 nitrogens, and if I double O5, I have 10 oxygens. Okay, let's compare over here. I have 2 nitrogens, but now I have 4 nitrogens. That means I need to double these nitrogens. That gives me 4 nitrogens. Okay, my oxygens still aren't enough. I have 6 oxygens right now. I need 10. So I need to change this 3 to be a 5. If I have 5 O2s, doesn't that give me 10? And it does. And now my equation is balanced. So what I mean by balance is we have the same number of nitrogens and the same number of oxygens on the reactant side as we do on the product side. Again, these big numbers in front are called coefficients, and they affect the entire molecule you're dealing with. So over here, if we have 2 N2O5s, then that means there's 4 nitrogens and 10 oxygens. Let's try another one. What if we have, let's see, what if we have sodium, and we're going to add that to chloride, and that is going to yield, chloride's diatomic, so it's Cl2, and that's going to yield NaCl, sodium chloride. All right, so we know that we have to really look at this in terms of like left and right. So we've got sodiums and we've got chlorines on both sides. On the left side, there's 1 sodium and 2 chlorines. And on the right side, there's 1 sodium and 1 chlorine. So our sodiums are good, they're balanced. Our chlorines are not. We need more chlorines in the products. So I'm going to double my sodium chloride. Remember, we can't change the subscripts. You can't add more chlorine without adding more sodium because they've bonded together. So that means I now have 2 sodiums and 2 chlorines. Well, now my chlorines are balanced, but my sodiums are not. So what do I need more of? I need more sodium on the left. So I'm going to double that. That makes 2 sodiums and 2 chlorine, and my equation is balanced. So my final balanced equation is this 2 sodium plus Cl2 yields 2 sodium chloride. Let's look at one more. What if we have nitrogen gas plus hydrogen gas? They are going to bond together and they are going to make ammonia. So what are we dealing with here? Let's see, we've got a left side and right side. We've got nitrogen and hydrogen on both. So when we count them individually, even though they're bonded, but we're counting the individual number of atoms. So on the left side, there's 2 nitrogen and 2 hydrogen. And on the right side, there's 1 nitrogen and 3 hydrogen. What's not balanced? Well, none of it. So what are we going to do? We need definitely more nitrogen. So if we double this, that's the only way I'm going to get 2 nitrogen is if I double the whole thing. That means I have 2 nitrogen, but that also means that I have 2 NH3s, which is a grand total of 6 hydrogen. Well, over here on the left, I have 2 nitrogen, so these are balanced, but my hydrogen is not, I only have 2. Well, if I double this, I'll have 4, but if I triple it, I will have 6, and that will give me a balanced reaction. Okay? This is pretty much how this keeps going. They can get complicated, and you can have multiple different elements. So like, let's say we have aluminum hydroxide plus sulfuric acid. Okay, so I've got a lot going on here already. And that is going to yield aluminum sulfate, SO4, 3, and water, H2O. Okay, so let's look at this. We're going to start by listing what elements we've got. We've got aluminum on both sides. We've got oxygen on both sides. We have hydrogen, both sides, and we have sulfur. Now, when we go to count this, we have to be super careful. So on the left side, how many aluminums? There's only one aluminum over here. How many aluminums on the right side? Just one. Oxygen. This 3 impacts the entire OH. So there's 3 oxygen. But look, here's 4 more because we're counting totals. So that really means we have 7 oxygen. On the reactant side, the product side, we have 3 O4s, which is 12, plus another one, that's 13 oxygen. Hydrogen, let's count hydrogen. There's 3 hydrogen here, plus 2 more right here, so that's 5 hydrogen on the left. And on the right, we've got just 2 hydrogen. And then if we count sulfur, I've got 1 sulfur here, just 1. That the subscript only goes with what it's in front of. And then here, I've got 3 sulfur. So 3 sulfur. Okay, so this is not balanced. Ooh, guys, I have a goof. This is actually Al2. Whoops. So I'm going to change this aluminum here to a 2. Okay, so when we try and figure out how to balance this, there's a few things we can look at. The only way to get the sulfur to 3 is to triple this side, right? You can't take like halves. You can only do whole numbers. So that's a start. We need to triple this. We also only have 1 aluminum, so this entire aluminum is going to need to double, that aluminum compound. So let's start with that. If I double this aluminum hydroxide, that gives me my 2 aluminum, and that's going to double everything else in this compound. So I had 3 oxygen here, but I double that for a total of 6. But don't forget, you still have 4 here. So that means we've got 10 oxygen on this side. And then what else does that do? That makes your hydrogen, so 3 hydrogen doubled is 6, plus 2 is 8 hydrogen. Okay, now we also said the sulfur needs to triple. So if we triple this sulfur, what does that do? All right, that gives me 6 hydrogen, and then don't forget I had 6 over here. So now how many hydrogen am I at? I'm actually at 12 hydrogen, 3 sulfur, so that's a new number, 3 sulfur, and then my oxygen, so over here I have 3 times, so 12, plus another 3 doubled, so 6, so that was 12 plus 6 is, 18. Ooh, I got a lot of oxygen. Okay, so now let's see where we're at. Our aluminum matches, our sulfur matches, our hydrogen and oxygen is a mess. Well, luckily, if hydrogen and oxygen don't match, we can just maybe adjust this water. So I need at least 12 hydrogens. They come in pairs. So what if we do 6 hydrogen? That gives me my 12. And then what's that do to my oxygen? Now I have 6. Plus I had another 12 here. 6 plus 12 is a grand total of 18 oxygen. Let's recap. Okay, now I have 2 aluminum, 18 oxygen, 12 hydrogen, and 3 sulfur. And I'm done. Now this would be an example of a really difficult one, but you can see it's still very manageable if you keep following those same steps. The key to remember is that you can only adjust coefficients as whole numbers, and they affect every element in the compound. The subscripts only go with the number that they're right in front of, unless there's brackets. That 3 means that you've got a triple O4 and a triple S. So you just have to be really careful with your counting. It always helps to set up a kind of balance sheet like this, and you'll be on your way. Okay, I hope that made sense. Bye.